I'm just going to go ahead and get started as people come through. If they join a little bit late, it'll just be during the introduction, so they won't miss too much of the real content. So thanks for your time this morning. I'm hoping not to take too much time out of your day here. I'll try to keep it around 30 minutes overall. Basically, I'd like to go into the idea of digitizing the supply chain, and especially in times like right now with the global pandemic, it's important to at least understand this concept. So my name is Evan Schwartz. I'm our 3D equipment sales manager here at Neometrics. We specialize in pretty much anything 3D, from hardware to software, 3D scanning, 3D printing, reverse engineering, and inspection. So both on the service side, but also on selling and training, we do pretty much everything under the sun regarding 3D. So if you got a 3D problem that isn't covered in today's presentation, feel free to reach out anyway. We likely know about it or know who to send you over to. So that's just a little bit about us. The agenda for today, if I can get my slide to advance here, is I just want to take an introduction period to take a look at the issues that we're facing currently, not just with the pandemic, but with just the way that supply chains are operating in today's age. I want to do a breakdown between traditional and digital manufacturing, what those words mean, because they really are buzzwords, right? So take a look at what we mean when we say these things, and you hear these types of words, out there in the field. What are the benefits of using a digital supply chain, and how does that look? And then why should you care as well? Like I said, you might see these buzzwords all around. People say digital supply chain, digital manufacturing. Why does it matter? I want to show you a few real world examples based off the products that we carry. Obviously, they're not representative of everything, but I want to show you at least a few ideas to get the ball rolling, and maybe inspire you guys to do a little bit of innovation of your own. And then lastly, I just want to end on some new material developments that we see upcoming, mainly the release of 3D printed coppers, just because it's a very hard material to machine and braze repeatedly and accurately. So the ability to 3D print pure copper is a huge bonus. So I just want to talk a little bit about that at the end. And then obviously throughout the presentation in the chat window, feel free to put any questions that you've got. I'll periodically go back and check in there. But if I don't get around to it during the presentation, I will see your question at the end and make sure I get you an answer. All right, so let's get started. So now more than ever, the world is really powered by technology. How we communicate, how we buy and sell, our online banking, everything is moving towards digital, and that's manufacturing included. And the future is really revolving around AI, robotics, automation, ways to make everything completely seamless and reduce any hiccups along the way. Oddly enough, though, the way that we create parts has largely stayed the same. So let's take a look at, for thousands and thousands of years, humans have been making parts by taking a raw material, be it stone, wood, metal, whatever it is, and chipping away at it to create a part, right? So you have a big block of material and you're removing material in a subtractive method to create your end use part. And that's how everyone thinks about manufacturing. Things like casting and other forms of additive manufacturing that are a bit more traditional, those are really the only additive manufacturing methods that we've seen that have become like a mainstay until 3D printing. Another thing that we're facing today is a real skills shortage. So machining these types of parts accurately, especially on manual machines, is a skill that not a lot of people have. And there's a huge age gap between these skilled machinists, between guys that have been in the industry for years and years, that are hitting their 50s and 60s right now, and young people that are just getting out of technical school right now that don't have that experience. Less and less young people are becoming machinists, tool makers, and the like. And that's something that companies need to be forward thinking about. Once parts are created, we have to ship them all over the world, and this can take up to months depending on what the parts are, how large it is and where it has to go, and things like trade wars, emissions, and a lot of other factors are going to affect the time and cost that is associated with the shipping of these parts globally. And all these things are ever changing as the world shifts. And that's something that's very hard to manage at a company level. And what happens to these parts when they arrive? Well, in many cases, they sit on a shelf in a warehouse. In fact, 70% of the world's spare parts are never even used. So increasing inventory means less cash is available for you to operate your business. That's a huge opportunity cost that is between inventory, warehouse, leasing, and pretty much all the costs associated with having these parts on hand. And so we live in a world that heavily relies on just-in-time inventory. And when we experience a crisis like this year's pandemic, that severely impacts how companies can manage this inventory. So over the last several months, we've seen some pretty huge impact in the ways that it brings a lot of these supply chain issues to light. These things existed before the pandemic, but the pandemic really highlights a lot of it because when let's say you get delays on one part of your supply chain process, that bottleneck is going to affect everything else that you do. So how do we keep production going in these times? And how do we rapidly retool to change over our lines to create new products? And how do we avoid outsourcing so much that our business would fail if something were to happen? Well, in order to answer that question, I want to take a look at the way manufacturing is done now versus digital inventory and on-demand manufacturing. So on the left, you see here is the standard process for creating a part. So you'll design something and you prototype it, and with that, you have to create prototyping tooling, go through multiple iterations until you figure out exactly what you want your part to look like. And then when you go into actual fabrication, you have to create fixtures, tools, jigs. You have to program your cam depending on what your method of manufacturing is, and then go into production and eventually ship your product. Digital means anytime, any design, any place. So imagine having all the sites of your company having access to the exact same part files, tools, fixtures, without having any physical inventory. Instead, when you need a part, you just look it up and you hit print, and everyone has the exact same part that's coming off the machine, and it gets to you in a couple of hours rather than having to wait to get it shipped to you overnight even. So this is a great reduction in lead times. It gives you a lot more control over your supply chain, and oftentimes it reduces costs, especially that inventory cost you were talking about before. And what does this shift look like, when you look at the various aspects of running your supply chain? So manufacturing, less is going to be done offshore and more of it's going to be done local. Your tooling is going to be a lot cheaper. So that allows you to do more in-house. Logistically, you're going from off or global to last mile logistics. In terms of new product development, your slow iterative design phases are becoming much, much faster, and you're getting your data much quicker. So you're able to design new parts in a matter of weeks as opposed to months or even years. Your production costs are lower. Like I said before, your tools are cheaper. You might even be able to print end-use parts out of some of these materials. And then in terms of demand planning, a lot more of it is under your control. The more that you're doing in-house and the more that you're able to rapidly iterate on, the more predictable your demand planning will be. And why is this important and why should I care? Well, in the last 15 years, 52% of Fortune 500 companies have disappeared. And the average lifespan of these companies is rapidly declining, as you can see here on the right. And why is this? Well, in a digital age, it's easy to get left behind because technology is rapidly advancing and helping new companies push out others that are stuck in their traditional ways. Products are getting to market much faster than ever before and for less and less money. So there's a lot lower of a cost barrier to get into some of these industries. I don't have all the answers, of course, to help you solve these problems, but I would like to show you maybe a few small ways that companies are doing this today, making this shift today through additive manufacturing. This isn't an end-all, be-all solution, right? But I'm hoping that I can inspire some of you at least to take some of these lessons back to your businesses and learn a little bit from here. Um, and I just want to take a look at the U.S. military as well. I mean, wars have been won and lost primarily because of logistics. We're seeing more and more usage of additive manufacturing uh, for the military and their global supply chain. Instead of shipping hundreds of spare parts into the field in the theater of war in hard to reach locations, instead you can send a printer with a few files, right? And that takes up much less space. Repairs and maintenance and other tools can be created on site, and there's no way to plan for everything that's going to go wrong. And there's no way to send a full warehouse of parts everywhere you need. So tools like additive manufacturing are affecting really any industry. So let's take a before we take a look at a few real world case studies. Um, I just wanted to take a look at some of the issues the current climate is imposing on us, and how can additive manufacturing help with these. So as far as costs go, um, these are increasing when outsourcing is limited. The more control that the suppliers have over the market, the higher that price is going to be. Everyone's looking to buy, and not a lot of people have staff on site to sell. Product launches are taking longer when you're relying on too many sources, outside sources, for various stages of your prototyping. If you're outsourcing your tools that you need to prototype, that's adding weeks to your lead times. Just in time was great, right? But it's not robust enough for a rapidly changing environment like we're in today. And it's very hard to predict. Um, you know, as opposed to something that's much more robust and can turn on the dime, like the digital inventory can. Sadly, there's a reduced workforce currently, and we are working hard to accomplish the same amount of work with less people. Demand is changing rapidly. How do we accommodate for this? And how do we make the transition into digital logistics from traditional? And how do we reduce costs by reducing inventory holding? So keep a lot of these questions in mind as we go through these real world examples. A lot of them will touch on all of these, and some of them will only touch on a few. But these are good questions to be asking yourself as you're taking a look at your own supply chain. So I'm not sure how many of you are familiar. If you've watched our webinars in the past, you're probably pretty familiar with Markforged. But the main benefit of using a Markforged 3D printer is part strength. As materials are getting stronger and stronger, you're able to print more and more end-use parts like your tooling, your jigs, your fixtures, and even replacement parts that might be out in the field. Um, Markforged is special in the case that you're able to print continuous composite fibers as well as metals, so you get the strongest parts in the market with the ease of use of an FDM style 3D printer. So there's not a whole lot of learning curve, and you get parts that can replace, up to aluminum strength from the plastic side, and one-to-one replacements on a lot of different alloys of metals. So a lesser-known division of Siemens here in Florida is responsible for generating innovative ways for their field teams to rapidly solve problems. They have been a huge power user of 3D printing in the past, and they actually designed this cutback tool that you see here on the screen now, which is used to maintain turbine systems in the field. The original design of the off-the-shelf cutback tool didn't really work very well on contoured surfaces because the guiding plate was flat. So what they had to do every single time they wanted to purchase a tool is send it to the Philippines to be disassembled and then reassembled with a curved guiding plate. And that was far from scalable, as you can probably imagine. So what happens if they need multiple of these tools at once? And for Siemens, minutes of downtime is a huge millions of dollar opportunity cost that they're experiencing. So the ability to rapidly iterate and produce this prototype tool that you see on the right was it was just something that was the only option for them. And it actually ended up working so well that these are end-use parts that they have in the field today, end-use tools. Each time that they make one of these, it's $8,000 in savings, and they're saving 35 weeks, by being able to print it in-house and then ship it out, or send the file to the on-site locations that they have if they have a Markforged printer on site. Mica Systems is a Canada-based company in the mining and cement industry, and they do a lot of these crucible clips that you see here on the left for melting down platinum. Previously, they were outsourcing these to additive manufacturing. So they were, relatively quick turnaround time. But when you're going through multiple iterations and honing in the design, that lead time of outsourcing is still pretty great. So they were shipping these out to get made out of Inconel 625 on a DMLS system. Instead, they took a look at the Markforged Metal X to bring production in-house. They were able to go through and rapidly iterate their designs, and now they saved currently almost the cost of the machine within a couple of months, and their lead time reduction is incredible. So they do most of their manufacturing in-house now because they're able to produce all these parts, even these complex alloys, easily at their own Metal X. Shukla Medical, they're a division of SS White Tech out here in Florida as well. And they've been using the Markforged Onyx material for a while. Originally, they got it to create functional prototypes that surgeons can use so that they can actually hold and test the equipment that Shukla Medical is designing for them. So these parts that you see here on the left, you can see the original design was printed out of onyx, which is a nylon with chopped fiber in it. The middle is the 3D printed part, and the one on the right is the end-use machined metal. So although they were getting valuable data from the onyx parts, from their doctors that were testing out the parts, they wanted more than this. They wanted the exact tactile feel and weight of the parts that are going to be the end-use product, right? So they wanted that one-to-one material relationship. So these were made out of 17.4 pH stainless steel when they're finally produced. So now they're able to print them out of that same material when they're going through their iterations, prototyping, and they can get much more accurate feedback and quickly get their parts back without having to pay high tooling costs just to make prototypes. So if you think about the amount of time that it takes to tool up, cut out your part, just one of them, ship it out, get data, get your feedback, and then do it all over again, you're taking that months and months of time down to maybe 3 days to print your part and get it out there and get your feedback back. So it's a very, very quick cost and lead time savings here. So lastly, I just want to take a look at some of the latest in Metal X technology. The last material that we released is this 3D printed copper that you see on the left. A global automotive manufacturer has been using this for a while to create welding shanks, which is that part there. The name of the company will be released in the future. I just don't have the authorization to say it as of yet. So let's get into the details here. On the left, you see the machined copper welding shank that they've been using for years, and on the right is the Markforged 3D printed version. So believe it or not, copper is very difficult to machine. If you're familiar with it, it's often compared to machining bubblegum. And the tool on the left cost almost $25,000 between all the prototypes and iterations to finally get honed in. And the lead time is about 12 weeks, between all of that. And because it's so critical, they don't just need one of these. They need, many configurations, and they need replacements. If one goes down on an automotive line, they measure, their downtime in seconds. So any second that they're down is a huge opportunity cost. So you can easily see how these costs are adding up when they have to have a whole mess of these $25,000 tools just sitting in inventory in case something happens. So instead of machining these at a house, they decided to test our 3D printed copper to print these in-house and reduce their inventory costs. So when they know that one is nearing its end of life, they can just start printing the next. So as you can see here, since it's a pure 3D printed copper, it's performing nearly the same as the machined versions. The printed parts stayed between 50 to 70 microohms, and that was the required range for this test. So the customer is very pleased in the end. Copper is very famous as a conductor of heat and electricity, so the resistance value matters really greatly here. Other 3D printed coppers, and this is just important to note here, other 3D printed coppers are typically alloyed, so the resistance value is different than a traditional machined copper. Because most metal 3D printing systems use a laser, pure copper is too reflective for that laser to be effective. So our system, since it mirrors something like a metal injection molding process, we're able to print that pure alloy or that pure copper and get the exact same results as the machine copper. And as you can see, hold on, let me, it's not transitioning here. It stays consistent between the welds. So you can be rest assured knowing that your 3D printed part is going to perform just as good as your machined part. So I hope some of this has inspired you guys to take ideas back to your shop floor and your supply chain. Obviously, if you've got questions, throw them in the chat, and I'll get to them in a second here. I'll leave you with a quote from the manufacturer regarding our 3D printing copper. So I've always been impressed with the technology behind the Markforged Metal-X system, and our experience with 3D printing copper has been incredible, especially when looking at its conductivity and structural stability. And now we've successfully evaluated weld testing. We plan to expand on expanding our metal 3D printing capacity for this and other metal components. 3D printing copper with Markforged is faster and more cost effective than purchasing complex machined components. And we expect it to help us mitigate downtime exposure and reduce inventory cost by $200,000 a year using just one Metal X system. And just so you guys are aware, $200,000 a year, that's essentially your ROI right there, including all of your installation costs and training. So if you get ROI in 1 year and some capital equipment, I mean, that's a pretty good sign. That's a good choice. What else can you use copper for is something that we get asked pretty often. So you have to take a look at its strengths, its thermal and electrical conductivity. So heat sinks, thermal transfer, the miniaturization of equipment, like for drones, for example, would be a good fit. On the electrical side, things like bus bars and complex pieces that are a lot easier to repeatedly print than manually braze. If you do a lot of copper manufacturing, you probably do a lot of brazing, which is not fun. So I'm going to pull up the questions here, if there are any, and let's take a look. What kind of files do we need to 3D print spare parts? That's a great question. So, as with any other 3D printing technology, you use your STL file. So if you've got your CAD that you would send out to the machine shop, you just export that as an STL, and you're able to get your spare parts within a matter of days on the metal side. So I mentioned this at the beginning, but that was before everyone had joined in. Oh, okay. I got one more question coming in here. What if we don't have a CAD file? If you don't have a CAD file, there are ways to get one through 3D scanning and reverse engineering, which is another one of our core competencies. If you take a look at some of our other webinars, you can see exactly how to do that on a step-by-step basis. But essentially, we can take a part that you've got that you don't have the CAD for, scan it to take all the measurements, and then build a CAD file with one of our reverse engineering tools. And depending on the complexity of that, that could be anywhere from 30 minutes to only a couple of hours, because we have some pretty powerful tools in-house. If you've got questions on that kind of thing, give me a shout at my email that you see on screen, or just reach out to us on our website. One thing that I mentioned at the beginning, before people joined, was we just started a short video series. Each video is about 2 to 3 minutes long, and we plan on releasing, a couple of months or so on ways to get more out of your 3D technologies. So we're starting off with 3D printing, basically ways to get stronger than plastic out of your plastic 3D printed parts using off-the-shelf inserts. So we started with threads. We released our first video on Monday. We are likely releasing our second video this coming Monday. And we'll take a look at just ways to strengthen your Z-axis. If you're familiar with FDM, Z-axis is often weaker because you're relying on the lamination strength between each layer. So strengthening your Z-axis, using inserts for threads, and then designing parts for high wear applications that you would typically machine out of metal. Oftentimes you can get away with just 3D printing a plastic part and using things like shaft keys and dowels inserts to reduce the wear. So check those out. Sign up for our email newsletter, and you'll see those come through, or you can just follow our Wistia page there. All right. Well, thank you for everyone's time. I don't see any more questions coming through. If you think of anything, feel free to email me, and look forward to next webinar.